So this is the session about STEM, science, technology, engineering, and mathematics. And the questions are many questions. These are the people who are participating in this panel. And I will start talking about STEM. I will start talking about what bothers in our case. I am from Tel Aviv University, from the School of Education, for many years working on science and technology education. What bothers us is the T and the E, technology and engineering. What does it mean to deal with technology and engineering in terms of concepts, contents, teacher training, technologies to be developed, and so on? There are many different answers. And one of the answers is the classical answer. We need to teach these kind of topics at all age levels because we need in our society, for economical reasons, the next generation of engineers, workers, high-tech people, and so on. This is the socio-economic and technological perspective. I think it's very important because it's important for the economy, it's important for the society, but we are in education, we are a school of education, we're talking about learning, and our perspective is a little bit different or is complementary. Our perspective is doing technology is part of being humans. Doing technology is part of the gift we got, our mind, a mind which is able to invent worlds, to solve problems, to do technology. As I used to say in our courses dealing with learning technology, humans do technology because they are humans. Humans are humans because they do technology. And it's the same thing, and we cannot afford the luxury to neglect the formation, the support to develop these kind of capabilities, and we should start very early in schooling. I will skip this one. How we do that? We are a unit, academic unit in a research university. So we do the whole cycle. Basic research, applied research, and implementation, projects, development and implementation. We do basic research because we want to know how people learn technology and engineering. And also, at the end, we do implementation because we are education. We want the people to benefit from the knowledge we create in the university. So, 3 short examples in the different stages, among many other things we are doing in the School of Education. The first one, and we heard about bridging the traditional world, the world of books, of textbooks, of print books, and the new era of technological tools, the new era of digital instruments. This is our curriculum. We are 40 years now working on the science and technology curriculum for K-6 in the Israeli schools. These are traditional print books. Today, and for many years now, they are enhanced with the digital and other technological components, some of them in close cooperation with CET, and is about 25 years, I think, cooperation, doing this kind of things, very fruitful cooperation. And this curriculum, if I can give the bottom line, this curriculum is now, or these materials are now in the vast majority of Israeli schools. I don't want to say all because it will be too much, but in the vast majority of Israeli schools, children from K-6 learn with this kind of materials, print, digital, computer-based labs, and other things. This is at the stage of implementation. This is in the second stage, the applied research stage. We conducted for many years, in fact about 20 years of work in educational robotics. We asked many different questions about what does it mean for children to meet control systems, robots, adaptive creatures. It's like you have living things and non-living things. Now you have non-living things that behave, that learn, that make decisions. So we did the basic research, and now we are in the phase of applied research in the sense of we are developing all these kind of tools. For example, in the left part of the screen, children like to play with puzzles, to build puzzles. This is what children do in the kindergarten. So this is a tangible language. Children build programs and construct programs using the puzzle. You can see here a complete programming language with all components, all kinds of inputs, outputs, sensors, effectors, and so on. The computer is taking care of transforming the puzzle into a real computer program to control a device, to control a robot. And the other side is a visual language, is now in use in many different, kindergartens in Israel, is now being tested in the App Store. Hopefully in a month from now will be available to use in kindergartens all over the world. Is not language dependent, is being used now for many years by our children in our kindergartens. And the third example is something that is in a very preliminary stage of basic research. The idea, and I don't have time, so the idea is instead of bringing the world into the school as idealized representation in a textbook, in a picture, in a movie, in a computer simulation, let's take the students and the school to the world. This project, pervasive learning system using context-aware, Internet of Things, augmented reality, personalization technologies, the idea is for any real-world setting, in a factory, in a botanic garden, like the example we are working on now, in a lab, in a science lab, to become a place where people come to learn with their own devices, do research, do science, do technology. As we say, the tree and the children, they talk with each other. The tree, we supply the tree with all kinds of hardware and software additions, and people are learning in real-world settings and not with representations of the real-world settings. These are only 3 examples of what we do in the School of Education. And now my time is over, so I will give the microphone to the next presenter.